Good morning, everybody. I guess it's good afternoon now because it's after 12. So, hope you're all doing well. Oh, the iPad is not connecting. One sec. So, this is for Algebra 1. We are going to be graphing linear inequalities. So, this PDF is in Teams. Hi, Ethan. If you couldn't print it, that's totally okay. Do your best to sketch the graphs. I'm more or less worried. Can we make sure we're shading the right way? All that fun stuff. So don't worry about that. And your homework tonight will be in Delta Math. So we have graphed one linear inequality on a graph. And the difference with today's lesson is we're going to be graphing two together and seeing their solution set. So not just where they intersect, but where does their shaded region intersect. So if you want to grab like two different colored pens or a pen and a pencil or two different colored pencils, sometimes it's easier to see that way where their intersecting shaded regions are. In the meantime, I'm just going to write some notes down here at the bottom just to refresh our memory on graphing a linear inequality. So remember that there are two different kinds of lines. There are dashed lines, and there are solid lines. So a dashed line would be something where you have strictly greater than or strictly less than. A solid line is going to be greater than or equal to, less than or equal to, or if we weren't dealing with an inequality, it would just be a regular equal to line. So make sure you get that down. And then to figure out where we are going to shade, so to find the shaded region, wow, I can't spell today, can I? I really can't spell any day. To find the shaded, Find the shaded, use a test point. And remember, when possible, 0, 0 is always going to be the easiest. So 0, 0 when possible. The only time we would not be allowed to use the test point 0, 0 would be if our line physically crosses through that point. So it has to be a point that is not on the line itself. So give you a second to get that down. And then I'll scroll back up. We're not going to do a bazillion examples. I'm just going to do a few. And then again, your homework is in Delta Math. Some of the questions in Delta Math, though, were not written in slope-intercept form. So you may have to get that in slope-intercept form first. And just remember, when you're dividing by a negative, your inequality symbol will flip. So just be cautious of that. Okay. And if I'm going too fast, just let me know. So let's get started. So at number 1, we have our two inequalities, and I'm going to write some notes next to each of them. So our first line is y is greater than or equal to. Because I see greater than or equal to, I'm going to write solid next to it so that I know that it's a solid line. I'm also going to state my slope and y-intercept. So my slope is 3 over 2. And my y-intercept is going to be 4. Now, if you're still struggling with graphing in slope-intercept form, that's totally fine. You can use your y equals and plug in your table of values in your calculator to see what all the pretty points are going to be. All right, so let us graph. So if I'm starting at 4, I'm going to put my dot there, and then rise over run. So I got to go up 3 over 2. Up 3 over 2. And then I just like to keep my graph continuing, so I'm just going to go the opposite. I'm going to go down 3 over 2, down 3 over 2, etc. And this one we did say was solid. So we do want it to extend through the entire plane. So we do want that to extend through the entire plane. Okay, and I'm going to do a lot of long pauses here in case you're graphing this with me. Okay, we also need to do a test point. So TP, not to be confused with toilet paper, but it is test point. And I'm, of course, going to use 0, 0 whenever possible. So in this case, if I plugged in 0 for x and y, I would get 0 is greater than or equal to 4. Is this statement true? Nope. It is false. So I'm going to shade away from 0, 0. So since 0, 0 is there and it did not work, I'm going to shade the part of the plane that is away from 0, 0. Okay, and there we have it so far. I'm going to pick a different color now. For y is greater than 7. So y is greater than 7. Well, since it's strictly greater than, this is going to be a dashed line. And if it's strictly just y, it's going to be a horizontal line. So it's dashed and it's horizontal. So that means I'm going to go up to positive 7. And my line is just going to be horizontal going all the way across. And again, it's dashed. So you can draw a few dots there, but then it's just going to be dashed. And this one doesn't necessarily need a test point. If I'm thinking of numbers that are greater than 7, that's 8, 9, 10, blah, blah, blah. So we're going to shade above. So the solution to this problem is any point that is in that double shaded region where the pink and the blue overlap. And I'm just going to highlight that area. So where the pink and the blue overlap, that is all here. So where I'm highlighting, and if you want to highlight too, not a bad idea, where I'm highlighting, that is our solution. So I'm going to do my S circled so I know all of those points in the shaded region are answers to both of those inequalities. But it can't be on the dashed line. So if you're saying that 0, 7 is a solution, that is not true, because on a dashed line, of course, those points are not solutions. Okay. And again, let me know if you want me to slow down. Not a big deal. And I'm going to skip around on this worksheet because some of the slopes are just nuts. So I'm going to scroll down. Whee! Let's do, this one's not too bad. All right. So we've got 2 inequalities written there. I'm just going to start with the top one. So we have strictly greater than, so this is going to be dashed. And I'm going to state my m, my slope, which is 5/3. Again, remember, slope is rise over run. And I'm also going to state the y-intercept, which is 3. So we're labeling it dashed. We don't forget to make it dashed. We have our slope and our y-intercept. So we're going to start up at 3, and then I've got to rise up 5 and go to the right 3. So 1, 2, 3, 4, 5, 1, 2, 3. This is a pretty large slope. So I'm looking like I can only fit 1 point that way. So if I want to go down the other way, I'm going to do the direct opposite of rise over run. I'm going to go down 5, 1, 2, 3, 4, 5, and left 3. 1, 2, 3. Just so I can get at least another point in there. You know, I like to graph as many points as possible. 3 would be the bare minimum. And then this is going, I'm going to get one more point in there. 1, 2, 3, 4, 5, 1, 2, 3. All right, that's a little bit better. Because I want it to be as accurate as possible, especially when we're doing a dashed line. Like, I don't have a straight edge to go off of right now. Luckily, you do because you're at home. So I just want to make sure I'm graphing this as best as I can. Okay, so that's our first line. I really should label these. Shame on me. You should have said shame, Mrs. Sadler. You didn't label your line. Shame. Shame, shame. All right. Actually, I'm going to label that below because I need that space. Whee! Okay. So next we need to do our test point, not to be confused again with toilet paper. And does not go through the origin, so winner, winner, chicken dinner there. So again, we're doing this for the top line. We have, if I plug in 0 for x and 0 for y, I get 0 is greater than 3. Is that a true statement? Nope, it is false. So I'm going to shade away from that point. That did not work. So shade away, away, away we go. Actually, I want pink. I like pink. Cool. All right. Oh. Ah, sorry. It's my husband's iPad. He keeps getting notifications. All right. So next, we're going to do the bottom line, which is strictly greater than. So I'm going to make this dashed. And again, I like to use 2 different colors because visually for me it's very helpful. We have a slope of 1/3 and a y-intercept of 7. And again, this is dashed, so we're going to go up to 7 and then up 1 over 3. Up 1 over 3. Up 1 over 3. And then if I want to keep going down the opposite direction, I just do directly the opposite. So down 1 over 3, down 1 over 3, down 1 over 3. So you know me, I like to go through the whole plane. And then we're connecting these dashed. And I'll label it so you don't say shame on me, Mrs. Sadler. All right, and then we're almost done. Almost done. So we got to do our test point, and it doesn't go through the origin, so victory is ours. We can use 0, 0. So if I plug in 0 for x and 0 for y, I get 0 is greater than 7. Is this true? Still false. Bummer. That's okay. And if you're using the same like pencil or pen to draw these, try and make your shaded lines going in different directions so you can see where they like crosshatch. If you keep going the same direction, it's like, was that part of the first one? I don't know. So I'm gonna just go like this, the different direction. So even though I'm using 2 different colors, you can clearly see it, just in case at home you're not. And then if it is helpful, you're welcome to shade that region where they do intersect. So not a mandatory, but a good visual. So I'm going to highlight it. And then, but it would not be over, oops, a little messy there, until we put our S. Ooh, that's not very bright, is it? Let's try darker green. There we go. So we have our solution marked there. Okay, I'm going to do one more, and then I think you'll be good to go for your homework, which is going to be due on Tuesday, which is the date of your next video. I will post that in our Microsoft Teams later today. But your homework's already up in Delta Math. Let's see. Let's get one with a negative slope. We haven't done a negative slope one. Yeah, number 7's looking good. I'm going with this one. Number 7. All right. So, same process. Got to see, is this solid or dashed? So number 7, the first one is less than or equal to, so that's going to be solid. We have a slope of negative 6 over 7 and a y-intercept of 2. So we're going to start up here at 2. I'll zoom in just a little bit more. Now with a negative slope, got to remember you want your slope line to look negative. So we can still do rise over run, but I'm going to rise up 6. 1, 2, 3, 4, 5, 6. But instead of going right, I'm going to go left. So left 7. 1, 2, 3, 4, 5, 6, 7. And then if I want to get one more point on the other side, I can go down 6. 1, 2, 3, 4, 5, 6. And right 7. 1, 2, 3, 4, 5, 6, 7. All right, so that gives me 3 nice points. All right, so always be careful with that slope. And then again, we said this is a solid line. Oh, it's not making it straight for me. Come on, you know you want to. Aha, there we go. All right, the ending part was a little sketchy, but whatever. And I'm going to label it. Okay. And then next, we have to do our test point. Does not go through the origin. So again, I'm going to use 0, 0. So if I plug this into the first equation, we get 0 is less than or equal to 2. Oh my goodness. It's actually true. What? Yay, we finally got a true one. So that means I'm going to shade towards the point that was true. So towards the origin. Yay. Okay. Very good. All right. And then I've got my bottom line is a greater than or equal to. So that's also going to be solid. We have a slope of positive 2/7 and a y-intercept of -6. So we're going to start down at -6. Very large dot. And this is a normal positive slope, so up 2 over 7. 1, 2, 3, 4, 5, 6, 7. I'm not going to be able to fit one more to the right, so I'm going to make one to the left. So I'm going to go down 2 and left 7. 1, 2, 3, 4, 5, 6, 7. See if I can erase those little dots. Yeah, I can erase most of them. I'll just redraw those lines. There we go. All right. And then it's solid again, so we're going to extend that. Oops. Wasn't exactly perfect. There we go. Okay. Yeah, a little sketchy at the end there. What are you going to do? No straight edge. So y is greater than or equal to 2/7 x minus 6. And then the last step-ish is we need to do our test point, which again, 0, 0 is still fair game. So I'm going to get 0 is greater than or equal to -6. Oh my goodness, we have a true statement again. What are the odds? So that means since it's true, we're going to shade towards the point. That worked. So up and up and up and away. Whee! Look at all this fun shading we get to do. So much shading. And then if it's helpful, we can shade in the part of the graph. There we go. Big highlighter. Whee! There we go. There's our solution set. Got a little excited with the very chunky highlighter. There's our solution. Now this one's very unique. So because they're both solid lines, that point where they both intersect is also considered a solution. So this one's kind of fun because they're both solid. So I hope that was helpful to you. Not too different from what we've done. We're just graphing 2 lines instead of 1. No big deal. Are there any questions before I sign off? Okay. I'm not sure how delayed it is. I'm trying to watch it on my phone. Oh, it's very delayed. Okay. Very delayed on the phone. So, in other news, tonight my husband and I will be streaming some video games, probably around 7 or 8. Not sure what time he put on the stream. But we're going to try and do some where you guys can interact too and possibly participate. I know, Ethan, very exciting. So if you're bored tonight and you want to hop on Twitch when we're live, you might be able to play some games or at least watch us attempt to play some games, and it should be fun. So I hope you all have a fabulous day, fabulous weekend in Algebra 1. We will talk on Tuesday, unless you join me in my office hours, in which case I'd love to see your fabulous faces. So